Okay, good afternoon, everyone. Thank you for joining IPv6 Readiness Management Both. And today we have 4 speakers. And okay, let's start from the first speaker, Judy Pellet from IPv6 company. And he's going to introduce what would be the latest version, latest happiness for the IPv6 management, and also what happened in the IPv6 deployment. Okay, let's welcome Judy Pellet.
Okay. Oops. Yeah. In the middle. Okay. This is a new presentation. So probably I can find some mistakes while doing it because it's the first time I am presenting it. The idea of this presentation is basically making a kind of joke between the well-known film Raiders of the Lost Ark with the situation that the ISPs have when they try to deploy IPv6, right? So just like in the film, one of the difficulties of the IPv6 deployment for everyone since the beginning has been the lack of CPEs or CEs. In some texts we use the expression CPE for the home router. In some others we use C. It's exactly the same. So the difficulty to get CPEs with good IPv6 support, and basically good IPv6 support means that the CPE can run dual stack, but can run also transition mechanisms. In 2011, we had an ITF document which was RFC 6204 that was obsoleted with a new version in 2013, which is the actual one, RFC 7084, which is basic requirements for the IPv6 customer edge routers. And the thing with this document that right now is 5 years old is that it's only partially solving the problem. Why? Because this document was looking only to support IPv6 in the CPEs, but not actually to support the transition stage. So even if the CPE has support for a couple of transition mechanisms, it's not sufficient for what we are approaching right now. The document was meant for a world where you have still enough IPv4 addresses to run dual stack or to run 6-in-4 mechanism that is basically 6RD. That was the main thing of the document, right? So what happens is that for the big ISPs, this is not a problem because the big ISPs can go to a vendor and tell them, hey, I am going to need 10,000 routers, and these are the features that I want. That's it, done. They have a deal, and they will get whatever they need, right? But small ISPs, and I am talking about economies like Africa, South America, it happens sometimes also in Europe, and for sure it happens here, everywhere. A small ISP that may be 10,000 customers, or maybe just 500 customers or 2,000 customers, they usually don't buy big quantities of CPEs, and often they even go to the retail. They just go to the local supplier and tell them, hey, I need every week 10 CPEs. That's it. I don't need more, right? So what that means for them, they cannot get the features that they want for their network. They will not get whatever new RFCs get adopted that will facilitate their IPv6 deployment. And at the end, they end up having different brands, different models for even the same vendor, different features, and that means more complexity to do the operation and management of their network. At the end, what that means, the vendors also don't get the pressure to push for all the new features because the retail market is not telling them what is being asked for. So they are only pushing specific firmware versions for the big clients that they have, the big ISPs, right? Not the small ones. But what happened in the last years, we all know, the thing is that we have no more IPv4 addresses, so trying to deploy IPv6 with dual stack is no longer an option. People is or was deploying mechanisms like 6RD, which is basically tunneling IPv6 in IPv4. But again, this is no longer an option. What the people is doing? Well, the people is trying to do carrier-grade NAT mostly, and most of the big vendors are pushing for that. But this is not really an option for the long term. The carrier-grade NAT boxes are expensive. If in case you are doing that and you have not realized the problem, your IP ranges get blocked sooner or later. For example, PlayStation Network is blocking all the ranges that they detect are behind carrier-grade NAT. So you need to recycle the IP ranges that you are running on your carrier-grade NAT box, and you at the end will be wasting a lot of money in carrier-grade NAT boxes and again buying new IP ranges. If instead of that you buy new IP ranges and don't buy carrier-grade NAT, you will have less problems and will be saving some money. But of course, anyway, this is not the long-term solution. So in ITF, we realized about this problem at the end, not at the beginning, unfortunately. So we were starting to think that we need to find a way to survive in an IPv6 only world. Okay, so running dual stack will not be possible anymore, and we had invented new transition mechanisms to allow that. So we have what we call IPv6 only access networks, and then we run on top of them IPv4 as a service for the customers. So the idea is that you don't need any more IPv4 addresses in your core. You can even probably disable IPv4 in your core at some point if you have, for example, just residential users. And despite that, you are still able to offer dual stack in the LANs of the customers, okay? So, and I am not talking about that today. If you are interested in that topic, tomorrow in the morning I have a tutorial on that. The idea here is to tell you how we are supporting from the ITF to the vendors on doing that. So the thing precisely is, okay, from the ITF we have sorted out the problem. Now we are able to run IPv6 only access networks, but we need the CPEs, we need the Cs to support those technologies. If we wait for the market, we have the same situation as before. The market will not do that for small ISPs. The market will not do that for the retail products. They will do just for those big ISPs that ask for big quantities of CPs. So my idea 3 years ago was we need to update RFC 7084. And that's when my trip to this adventure started. I got adopted the document about 1 year afterwards in March 2007 in Chicago. And then in the next ITF, there was a pushback. No, we don't want that, whatever. Then finally, I got it moving on again. And it was adopted as a working group item in March 2018. And after 8 new versions and many intermediate versions in the middle for 4 new documents. So the original document is split in 4 different ones and then finally converged in the final one. It entered the last call in the middle of August, now passed the last call, and now is in the ISG review, which means that probably, if nothing else happen, in a matter of weeks, we will get this done as an RFC. So, oops. What means the IPv6 CPE, which IPv4 as a service? Well, basically, this document is specifying what is the necessary protocols for a CPE to run connected with IPv6 only in the one link to the ISP, but at the same time make sure the customers don't notice that they don't have IPv4 anymore. So the applications, the devices in the within the LANs of the customers will work transparently. And the idea is that this CPE is used by both the service providers, and also is the CPE that if any of us go to the market, to the supermarket, to buy one, they will get by default a CPE that should work in any ISP, despite what transition technology they are using. That's the goal of the document. So the document is specifying how to provision these IPv6 transition services, IPv4 as a service within the IPv6 network, to make sure that we survive in a world where we don't have any more IPv4 addresses, of course. So this is the actual name of the document, Draft ITF v6 Ops Transition IPv4 as a Service. As said, maybe in a few weeks, it will be already an RFC, hopefully. Well, this document is not suggesting the ISPs to run one or the other one transition mechanism. It's just telling the vendors what transition mechanisms they need to support within the CP. And the idea is also explain the ISPs, if you run any of these transition mechanisms, you have a single document instead of going to 10 documents to know how to do that, okay? So it's a help for the ISPs, but especially a document for the vendors to know what they need to implement. And also that can be used by the ISPs to say when they do tenders for purchasing CPEs, what we want the vendors support, okay? If you are a beacon ISP and you have the power to go to the vendor and tell them, I need something else, of course, you can specify additional features. That's not a problem. So the thing is, if you are a vendor, if you are providing CPEs, because it's impossible that you know in advance when somebody buy in the market a router in which ISP it will be connected, you need to support all the RFCs that we are mandating in this document. So basically you are going to support, I think it's in total 5 transition mechanisms. It seems very complex, but actually it's not, because most of these transition mechanisms have the same data plane and almost the same control plane. So it's not really that much difficult. So I am not sure, I am missing track of the time. How much time I have? 15 minutes? Okay. Because not having a counter here is difficult. Okay. So what are the requirements? We have different levels of requirements in this document. The first one is, in order to make sure that an ISP can choose which transition mechanism to use, we have defined a prioritization mechanism. So basically, without entering in the details, basically, even if the CP supports 5 transition mechanisms, the ISP is able to tell the CP which one the ISP want the CP to run, okay? So we are not saying, now you have a problem because there are 5 transition mechanisms, which one to use? No, the ISP is able to decide if they want to run dual stack, or if they want to run just IPv6, or if they want to run IPv6, which 1 out of 5 transition mechanisms. Very simple, right? What are the transition mechanisms? We have 464XLAT, we have DSLite, we have Lightwave 4/6, MAP-E and MAP-T. So the order in the slide is just alphabetical order. There is nothing else behind that, but it's true that my preference, and this is what I am telling everybody, is please go to 464XLAT. Why? Because this is the only mechanism that is able to work in cellular networks, and if you look at how many millions of devices already run IPv6, most of them in the world are with 464XLAT, and you can add all the others together, still don't reach the number that 464XLAT has. And in addition to that, if you have a cellular network and a broadband network, you don't want to run 2 different transition mechanisms. It's easier to have a single one, the same in both networks. So precisely for that, because 464XLAT was not very well defined for broadband networks, even if the original RFC for 464XLAT talked about deployment in both mobile and fixed networks, but it was not very well defined for a CPE vendor how to implement it. We have needed to work deeper in reporting how to do that. And well, again, I am not going to go into all the details, but that was really key to make sure that it works. And all what I am explaining here has been tested with open source implementation of CPEs. We have used it mainly OpenWRT, but there are other vendors that implemented also as well this mechanism, or this RFC. In fact, I was initially the only author of this document, but during the last year, I worked also with D-Link and with NAC, so they are also co-authors on the document, and they have implemented everything. We have also some changes from the requirements that we had in the slide in previous documents. Nothing special to detail here, but just for if you are a vendor, you really need to take care of that. And we have also requirements for Lightwave for over 6, MAPI and MAPT, which basically are nothing different than what the original specs are saying, right? We have also considered that the support for IPv4 multicast is important because there are many providers, many ISPs that are offering triple play services, and those services, the part of the video is coming by multicast. So if you are going to deploy an IPv6 only service, you need to make sure that you are still able to support IPTV by means of the IPv4 transition mechanism running on the IPv6 only network, okay? We have some requirements for UPnP, and also we don't support anymore 6RD because there is no meaning that we are deploying today 6RD while we don't have any more IPv4 addresses. That's it. I have studied also, because one of the complaints was, hey, if we are going to deploy or to implement now 4 or 5 transition mechanisms, that means a lot of extra code. Well, that's not true. Actually, implementing all the 5 transition mechanisms compared to just one is only adding 10 to 12 kilobytes of code, which is nothing, okay? So it's about 0.15% of the total cost of the code. And that's, we know, if you are a developer, you know that this percentage of code in the code of a router is nothing, okay? And everything is open source. Everything is available there. You don't need to write the code. You just go to the open source and implement in your own device. And furthermore, there are many vendors of CPEs from many countries, China, Taiwan, etc., that in fact are using OpenWRT, and they just change the skin. So it's even easier than that, right? They don't really need to do anything. So Indiana Jones was looking for the lost ark. We finally found for us the lost CPE for the IPv6 only internet. And just as a reminder, if you are an ISP, make sure to look for this soon to be an RFC, hopefully, in your new CPE acquisitions. So make sure to put that in the context of your purchasing departments. That will make your life as an ISP easier, will drop your operation and management cost, will allow your users to purchase a better router if they need that, instead of just using the cheap one that you are providing. And if you are a vendor, exactly the same. You are simplifying your manufacturing process, you have less firmware versions, you work with more ISPs in a transparent way, you have the same product in the retail market, and obviously that means you are reducing your research and development costs. And that's it. Thank you. Questions?
Any questions? Please go to the mic. Sure. Name and abbreviation, please.
Sure. Anurag Bhatia, Hurricane Electric. I have 2 questions for you. One is about the transition method. Why dual stack is not a good idea for the fixed networks, considering that many of the operators already have IPv4 in place on the access network? Why should they not use dual stack and bring another level of complexity? And the second question I have for you is associated to the first one. DNSSEC works in case of dual stack, while for any kind of NAT 6.4 mechanism, it fails.
Okay. The thing is, if you have enough addresses for your existing customer base and for growing, that's fine. Keep going with dual stack. I am not against that. But what I think is a very bad idea, and this is what is happening, is that because you know that you don't have enough addresses, and there was an article last week from, I think it was an Australian ISP, saying they have spent, and they will spend during the next 3 years, every year, $2.4 million in buying carrier NAT boxes, because what they are going to do is provide dual stack with private addresses, okay? So that means clearly they don't have enough addresses. And I think this is the situation for most of the people.
Just a clarification, I did mean dual stack with private IPv4, of course. You are anyway doing the translation, whether you do it on the access network, you know, on a CGNet router, or whether you do it somewhere far away near to the core and do not maintain IPv4 on access.
Do you know that Sony is blocking all the ranges that are in carrier NAT boxes? Because many people don't know that. And if you are getting your addresses blocked, and you keep changing your addresses, at the end you run out of addresses. And that means that if you have customers that use PlayStation, you cannot give them addresses behind carrier NAT, because sooner or later, even you have 1 million IPv4 addresses, you will recycle them through the carrier NAT, and Sony deny to take them out of the blacklist.
Do you mean Sony is blocking only for carrier grade NAT, or would they also block if it's a scenario where someone is reaching their IPv4 over a translation done from a NAT64?
It's the only problem they got is with the translation that is doing a carrier NAT sharing ports.
Okay.
Which NAT64, that don't happens. The difference between the translation in carrier NAT and NAT64 is that in carrier NAT you limit the number of ports per user. So each user is sharing an IP address with other 30 users, for example, sure. Okay? Which means also implications for law enforcement. For example, there is a publication from Europol that says, do you know that you are sharing the IP address with criminals? Simple. And I have seen cases of people being killed and not being able to investigate because the judge will not provide a court order to investigate 60 people. Okay? Sure. In the case of NAT64, you are sharing as many ports as each user needs at a given moment. So you don't have that limitation. It's a flow sharing, so you don't have that thing. Now, regarding your second question, the DNSSEC, my recommendation, and I have another ITF document, if you want to read that, it's a 30 pages document that recommends or suggests, actually the name of the document is Guideline for Deployment of 464xLAT or NAT64. And my suggestion is, in an ideal world, everybody that deploys DNSSEC should deploy as well IPv6. Then we don't break anything. But there is 1.7% of the world that is not doing that at the moment. And 1.7% is meaningless, but for a help desk or for an ISP, it may mean a lot of calls. So my suggestion is, if you deploy NAT64, you are tied to DNS64. No way. But if you deploy 464xLAT, you not. So you can deploy 464xLAT without DNS64, and it works. Okay?
Makes sense. Thank you.
Done? Thank you.
Are you done? Sorry, we have some small gift for speaker. So we need to take a, come here.
Picture. Thank you very much. Thank you. That's the picture. Yes. Thank you. Okay, thank you.
Okay, our next speaker is Valentin Ovra. Is talking about IPv6 only network for container or for orchestrations. Thank you.
Good afternoon. I will speak about IPv6 only network on container orchestration. I'm from a New Caledonian ISP called Notil, and I will mostly speak about system side and not network to customer deployment of IPv6. So here's a summary. I will start to explain what's a container. You probably heard about that because a lot of companies like Microsoft, IBM, Google, Cisco are working with container. And after that, I will try to explain how it can improve your company workflow. By workflow, I mean like the deployment process, development, application hosting, networking, and maybe the way you sync your company IT. After that, I will explain the networking of containers, how it works in IPv4 and in IPv6. After that, I will explain what is Kubernetes, container orchestrator platform, and how to get an IPv6 only network based on VM, because before got containers in IPv6, you need a network in IPv6. And finally, how to get IPv6 only orchestration for your containers. So first point is, what is a containers? A containers embed your application, its dependency in a tiny box, isolated using the kernel of Linux. So unless of virtual machine with virtualization using an hypervisor, container run on the same Linux host and are isolated by the kernel. So as you see, a virtual machine got an host operating system with an hypervisor and run few different operating system with app and dependency. A container embed application dependency and run on the same operating system. So just a quick demo to show the value of container and how quick it's to run an application based on container. So here I will launch a website based on WordPress. It's a PHP website with MySQL. And you can declare your container in a YAML file and just run it quickly. We'll see that on my laptop. I record it because live purpose. So here's the same file. It's a YAML file. I say I want a MySQL database and a WordPress container. I share the password using environment variable. And I just say docker compose up. It runs my two containers, the MySQL and the PHP one. I can check my container. I expose my container on the port 8000. I can check the log of the MySQL container. I can check the log of the PHP and Apache container. And now I can just check if my application is running. I will install it quickly to check if the database is reachable. Here you go, you got your website running on your laptop. Okay, so as you see, it's really quick to launch container on your laptop, and then you can deploy it quickly to cloud platform or on servers. So how it can improve your company workflow? First thing, I think the best part for me is you can use the same machine and scale different application of different purpose and different language on the same server. So probably if you use virtual machine, you create a virtual machine, put a website on it, and it uses maybe half of the resource. If you go to container, you can fit your server at its best size, so maybe you can reduce your cloud provider bills using container too. Another point, it's with container you create a manifest, so your developer writes a manifest of your application called a Docker file. For example, it's you Ubuntu one and you add Nginx, a web server, and you put your configuration file. So your developer have more knowledge of how the Linux configuration works, so it brings maybe more security, more portability too, so your application can work on his laptop and work on scale like 100 replica on cloud provider like Google has the same purpose, so it's a point. It's good to for continuous integration and continuous deployment. You can spin up test environment with container to test your application before deploy it in production. And it's part of the DevOps culture. I will not explain what is DevOps today, but globally it brings the operation team and the development team together to change the way you think your IT and develop more quickly by good practice, monitoring, etc. So here a look of our container networking. So by default, you got your network, your Docker host, which basic Linux server, and the container run on a different IPv4 space. So they can talk to each other. Your host can talk to container, but nobody from the external network can talk to container directly. If you want to expose a container, like I do in the first demo, you can use port binding to expose, for example, the port 8080 of the host to the port 80 of one container. It's done using IP table. If you want to use IPv6, you can define a fixed prefix on your Docker host, and each container will be created with an IPv6 from this prefix. If you want to expose publicly your container in IPv6, you can route this prefix to the Docker host, and then your container will be available in internet directly. So it's a good thing, but you need to put firewall and control who has access to your containers. As you see in IPv4 world of containers, there is a lot of NATing to join a container and to get out of the network, a lot of NAT. But if you enable IPv6, it's doing using IPv6 routing, so your packets are not rewritten to join the private network. So now, what is Kubernetes? Docker is great, container is great, but if you want to deploy containers at scale in hundreds of servers in a cluster, with great features like self-healing of your application, auto-scaling for node and application, service discovery, cron execution, storage orchestration, load balancing, you need a platform like Kubernetes. So our Kubernetes, it comes with few master nodes if you want high availability, and few worker nodes will receive containers. The master node is here to ensure you got the correct states you want and you got enough container running, etc. So we will quickly take a look at master of Kubernetes. It comes with few components. The first is etcd. It's key value store distributed using the Raft protocol, so it ensures the consistency of data. You can scale it, for example, to 3 replica, and you get high availability for your database. It's where everything is stored, the IP address, the number of containers you want, the names, everything. You got the API server, which is the major central component, which receives all requests from user and other components of Kubernetes. You got the scheduler, who is in charge to place your container to worker. So if you want 10 web application, it will check if your worker are ready to receive container and create it on your worker. And the controller manager is here to constantly check if you got enough resources on your worker, if you need to move some container to another worker. It's here to manage the states of your cluster. The worker node comes with 2 components of Kubernetes. The first is kubelet. It's mostly the agent who watch the API to create new containers. So it just checks, do I need to create? And if it needs, it creates on the Docker host. So you got the container technology, mostly called Docker, but you got other concurrent Like Rocket will be by Red Hat, so maybe in few months Rocket will be a great concurrent of Docker. And kubeproxy is in charge to expose your container using IP table rules for load balance your application if you use it, because we will see after in IPv6 we don't use kubeproxy a lot. And it comes with an interesting thing called CNI. It's the container network interface. So the networking of container is delegated to a plugin. You can choose which plugin you want to use. It comes with default plugin like Loopback, Bridge, and MacVLAN, but the third-party plugin allow more security, IPv6, and other we'll see after. Here's the CNI plugin we use in Nautil. It's called Calico. It's trusted by hundreds of entreprises like Orange, Yahoo Japan, USA, GitHub. It's simple, scalable, and secure. It uses pure layer 3 routing between hosts and shares this route with BGP, so basically like internet. So it's pretty scalable because you can start with 3 or 5 workers and scale to 100 or 1,000 workers without any issue of BGP like internet and router does. And more in depth, it uses Bird as BGP stack. It stores IP address, etc. in etcd like Kubernetes does. It creates IP table rules too if you need in your stack. And it's integrated with other platforms like OpenStack, Mesosphere, Kubernetes, and Docker itself. So you can try Calico just on one Linux machine easily. So here's a second demo running on an IPv6 only cluster, and show you how you can secure access to your container. Because I explained before, if you expose in IPv6 your container, every container are online in the internet, and maybe you don't want to get your database scanned all the day. So Calico make possible fine-grained policies, so you can define which container can talk to which other on which port. And the demo I will make is called star policy demo. So here is an example of network policy. You allow your MySQL application to get contact by your web app application on the port, MySQL port. So in Kubernetes world is mostly YAML file to define I want container, I want service, I want the volume for my MySQL container, etc. So you can define your firewall rules in YAML file too. So here's a demo. I got a Kubernetes cluster running with a front-end application, a back-end application, and a client we will reach the application, the back-end, the front-end, sorry, and a UI to visualize the stuff. As you see, here it's mostly ping that moving from front-end to client to back-end, and everybody can talk to each other. So my client can scan my back-end, so it's not really what I want. I will create first policy to default deny all the things. So I'll show you the file here. It's a YAML file, and I say default deny. So as we'll see, nobody can talk to each other at this point. So now I can't ping my container can ping to each other, and it's ingress rules. You can restrain egress too. So I show you final policy. I authorize my backend to get joined by the frontend on this port, and I authorize the frontend to be joined by the client on the port 80. I already applied the rules. And now, as you see, my client can talk only to my frontend, and my frontend can talk only to my backend. Nobody can Skype my frontend, my backend. Pretty secure. So now, how to get an IPv6 only network? As I said before, it's not about customer deployment, but only on our own network. If you want to talk to IPv4 only server, you need a mechanism called NAT64. We use Joule for that. It's made in Mexico, I think. And it's a pretty good tool. You compile a kernel module on your host, never mind the Linux distribution, and it do NAT64. So I will not explain what is NAT64, but if you want, just speak to me outside. If you want DNS automatically set up to your IPv6 only VM, you can set up RDNSSD. It's a pretty nice protocol that give you DNS already to your VM spawning in a VLAN. If you want to expose your services to IPv4 clients, it's what we do, for example, for our major website. We want all the internet can access to our website, but our website is running on IPv6 only VM. So we got a lot of couple of reverse proxy Nginx with dual stack on the side of our network, and the backend of these virtual hosts are IPv6 only. So you can use Nginx for HTTP, HTTPS, and HTTP2. You can use HAProxy for TCP, UDP stuff, and maybe Socat, it's more easy to just spawn a proxy. And if you want to secure things like NAT does, you need a firewall. And now, how you get an IPv6 only Kubernetes cluster? First point, Kubernetes is already IPv6 ready. So your API server can talk to etcd in IPv6. Your worker can talk to the API in IPv6. It works. If you use Calico, I don't know a lot about all other plugins. I know there is others that support IPv6, but Calico supports dual stack and IPv6 only without any effort. So you just say, I don't want IPv4, I want IPv6. You give them the prefix you want to use. You can choose different prefix in case of your application. You want public website application, you choose a prefix. You want database, you choose a different prefix. And if you want to disable totally NAT inside your cluster, you can create Kubernetes services with cluster IP none, so it don't create IP table rules to load balance your application. It just use round robin DNS, so your packet go to the worker and get routed to the final container without any NATing stuff. So here a schema of Kubernetes cluster. As you see, we use Joule for NAT64. We got a lot of worker here in IPv6 only. We got a master quorum in IPv6 who charge the state. We can lose, for example, one node here, never mind. We expose our services through Nginx ingress, so it currently watch the API for change and reload Nginx configuration dynamically. We use kubedns who expose services publicly inside the cluster. We use GlusterFS for example, you create a MySQL container here, but the data is here. If this machine go down, the container will be created here, but it access to the data too from the GlusterFS. And you got Calico that doing BGP announce to our network and make possible expose public IPv6 container on our host. Small IPv6 joke, just hard to remember. If you want more information about IPv6 and Kubernetes and container world, you can check my blog. It's an English one. I got a French one too. Thank you.
Any question? Okay.
Anurag Bhatia, Hurricane Electric again. I love the UI you used to show the ping. Can you share what exactly you're using just to show that it was reachable earlier before you applied the firewall policy?
It's a demo made by Calico team. It's pretty Python stuff that do ping and show it in JavaScript. So I think you can grab the source on GitHub. It's the star demo policy. I'll show you. Just type star policy demo on Google with Calico and you find the stuff and maybe the source code behind.
Thank you.
Thank you. Any question? Please, name and affiliation.
Hi, Faisal Abrani from Criteo. I am just wondering why you are not running Nginx in Docker also in your presentation.
To expose container to IPv4 client, we use external VM running BGP and Nginx dual stack, so we can create mostly automatically vhost and the backend is Kubernetes. But internally we use like dashboard tool and we expose it directly on Kubernetes in IPv6 only. And Nginx is running in Kubernetes and it's called Nginx Ingress, as I show here. As you see here, it's running on the cluster. But when we expose IPv4 website, we just forward to this Nginx, who finish forward to the final container, because it's dynamically reload if the container dies.
Makes sense. Thank you.
Thank you. Any last question? If not, some small token to you. Thank you. So our next speaker will be Anurag from Hirocon Electronics, talking about IPv6 growth in electronics. Thank you, Anurag.
Thank you.
Oh, okay. It's okay. Okay, it works. Cool. So, good evening, everyone. My name is Anurag. I work at a company named Hurricane Electric. We have nothing to do with electricity, just to clarify. I'd be talking about our experiences in deploying IPv6 and overall experiences from last 11 plus years around the V6. Quick overview about our network. So right now we are present in 6 continents with over 166 POPs in over 141 countries, and we are running a fully dual stacked setup. And I like the way Kenny has arranged these talks, because first we had Jordi, whose talk was very much focused around the last mile. Then we have talk around the containers on the other side. What you have left in middle is just the backbone. So I think it's where we can fill the gap in. We are running fully commercial native IPv6 from last 11 years. We run dual stack because we are a backbone operator, and essentially we do not have challenges around, say, NATing or around scaling up CG nets, because we are on the backbone side of the things. All our BGP customer connections are native, and we enable every customer on IPv6 by default. That's extremely important as per our experience, and if we have any of audiences in our room running IPv6, please do that. Do not keep IPv6 as optional, because customers are not going to ask you for it. Customers won't bother about IPv4. So if you want to say you have deployed V6, please do it by default. Don't let customer ask you for that. And that's more popular the case with the business connections, where users expect the IT managers to ask you for V6. It would be fun if your template just sends out in V6 and triggers curiosity in the IT admin about it. We run IPv6 enabled looking glass, and we have 24/7 NOC with IPv6 expertise. We do not have a single guy running V6 somewhere in the network. Everyone does V6. Everyone understands V6. I have taken this from today's morning from bgp.he.net, one of our tools, which some of you might have used. This tool is unrelated to our backbone, so the tool is collecting data out of various public route collectors, and we happen to come on top in case of IPv4 and IPv6 adjacencies. At this point of time, we are #1 network in terms of highest IPv4 and IPv6 adjacencies in the world. What is visible here is true, but whenever I say this, there can always be cases in BGP routing table of things which are not visible. So you can always have large content players with lots of peerings, but they may not be visible here because large content peering with smaller players and none of them feeding any public route collector, you won't really detect those peerings. So in our case, of course, we are a transit provider, so we do feed we do feed various route collectors, and hence hence our peerings are visible. Hence you see a number. We would love to see more competition around that. We do happen to be on top in case of IPv6 adjacencies, again because of the reason that we follow open peering policy, and we peer and we actually request all our peers to come and peer on IPv6 as well along with v4. About the mindset to make sure that IPv6 works and it's not just a feature or just an option. It's 2018, we are not talking in 2001, so the hardware is there. We don't need to debate about the hardware, at least on the core. Well, of course, we can have a chat about hardware on the hardware support on the CPE side doing translation, but core hardware is there. All the operating systems support it. I don't think I have encountered any operating system in last 5 or 6 years which has IPv6 support problem. I've always encountered various vendor devices, whether they are devices doing Wi-Fi backhauling, which do not support v6, but all the operating system, native stuff, hardware supports it. We have open source packages which support v6. So, all the web servers, whether you're running Apache, Nginx, supports IPv6 out of box. Whether you're running a mail server, supports IPv6 out of box, no challenges in there. So there's no strong reason at this point of time where you should not be running IPv6. And IPv6 expertise, of course, I think we have taken the name IPv6 a few million times so far, so of course IPv6 expertise is available at this point of time. A lot of work needs to be done around the core, and I'll come to that in my next slide about the core on what is the situation of v6 in the core. And the last point which I have put here is because it was there in one of my previous slides. I don't think I even need to say it here after Jodi's presentation that we should start to explore IPv6 only in the access for certain interesting reasons. I'll quickly talk about our certification program before jumping into the backbone part of the thing on support of IPv6 on the backbone. In order to promote v6, we did came up with the interesting idea, which was about free certification program. The logic is you gather interest in IPv6 by asking everyone to come for certification. What that certification does is that you prove that you have IPv6 connectivity. So it's an online test where you prove that you have v6 connectivity, you prove that you have a working v6 web server. You prove that you are able to get an IPv6 configured on the interface of a server. You are able to prove that you can configure a web server to listen to port 80 request on that. You prove that you have a working IPv6 email address. And don't forget the email address, important. I still see a lot of companies running their MX records only with A record, no quad A records. That's not a good thing. Please do publish your quad A records. Please dual stack your mail server. The next part of the test is you prove that you run an IPv6 authoritative DNS server with a forward record. So essentially we ask users to publish quad A records. We ask them to publish a reverse record. So as a part of test, you get an understanding of the reverse DNS working with the ERPA zones on how you make them work. What essentially these fundamental things achieve is that you make sure that everyone understands the format of IPv6 address and not just thinking it's just 128 bits and I don't know what else is there. You make sure that people understand quad A record and how it works. You make sure people understand one important part of IPv6, which is reverse DNS record. I really wish everyone understands reverse DNS, at least the network operator, and they start publishing those in the IP addresses which they are using on the backbone, so that you can make meaning out of trace routes. You make sure that people do understand default route. They understand what route they need, what is the default configuration they need with ::/0 to make sure that it works. and of course, a lot more around that. What do you get out of once you finish the test? Of course, you get a certificate and a nice T-shirt. Anyone in the audience who got this T-shirt? Can you raise hand? Anyone who finished our test and got a T-shirt?
I finished the test, but I never got the T-shirt.
Write me a mail. You should write me a mail. So the test is still up. The link is there on the slides. If you want to note it, it's here. It's ipv6.he.net. Oops, sorry. It's ipv6.he.net/certification, or you can simply go to he.net and look for certification. Try playing around with it, and definitely we are going to send you a T-shirt. Coming on to the next part of the presentation, which is routing table ready for real world use? And before we talk about that, you have to remember the backbones are the ones who should first push for IPv6. It cannot be the edge case. If an ISP sitting on the access network goes for pushing IPv6 without support of backbone operators, without backbone operators dual stacking, without backbone operators configuring all their peerings properly, it's not going to work, because at the end of the day, end user is going to face problems. So there is a harm for the access operators to take a lead in deploying V6 if backbones are not supporting it. So I would always say backbones, large operators, they should first do it. There's no harm in dual stacking the core, and then as you go and push it out to the end users, it makes a perfect sense. So is IPv6 routing table ready? Well, there can be two theories around it. One is plenty of backbones are running IPv6 routing, ours being one, and of course, most of other large operators are running V6 at this point of time. There's plenty of IPv6 inter-backbone peering. Almost all large to mid-size exchanges are supporting IPv6, and if your exchange is not supporting V6, please do start supporting it. If you do not have an IPv6 pool for exchange, speak to your RIR and do start doing that right away. The other theory can be, well, we are not ready yet. There are still few gaps in the routing table, and then still there's a bit of spotty cleanup which is required here and there. How many of people in the audience think theory 1 is true, and how many, can you raise the hand? Do you think IPv6 is ready for production use?
Yes, of course.
I think so. We do not need to think much about it. Of course, I will still say, well, there are gaps in the routing table, and a lot of the gaps are not because of commercial or intentional issues. It's more because we need to start treating IPv6 more seriously. If you're running a network, make sure your IPv6 peerings are like that of IPv4. Make sure that whichever session you have with any of your provider, whether it's your transit provider or whether it's your peerings or whether it's with your customer, do start dual stacking them. As long as you have that, you would have exactly similar or probably better performance. At least beyond routing, there would be a lot better performance with IPv6. I'll give you an overview about bgp.he.net, one of our tools, which we built around with the idea of looking at the routing table with focus on IPv6. You can have prefix reports, so you see prefixes, ASNs, as well as how routes are being propagated. Again, bgp.he.net routing information is not based on our backbone. That is based on various route collectors, various public route collectors. So it's a report which is much more comprehensive than the view which our backbone would have at a given point of time. We have BGP peer report, and this may be a very interesting report. If you go to our tool and you go on the country, you can find all the countries listed in there, and you can select any country, see the ASNs which belong to that country. I'll show you a view of that. This is a view of New Caledonia, the ASNs we see at this point of time, along with the IPv4 and IPv6 adjacencies, as well as the routes which an operator is originating and carrying. Whoops. Apart from that, we also carry information about bogons in IPv4 and IPv6. And we also have the information about the top host. It's getting noisy. We should focus back on the presentation. And we also put the information about the top hosts as well as internet statistics around how many routes are there in the routing table at a given point of time. This is the data from today, and we update this data every 24 hours. So this should not be older than 24 hours at a given point of time. Right now in IPv4 table, you have 62,914 ASNs, and in case of IPv6, it's only 16,000. That's a big difference, isn't it? So a lot of work needs to be done, at least on the ASN side. More and more ASNs need to start originating IPv6 pools. So if you are in the room, if you do not have IPv6 pool, get one. If you have one, please start originating it and start subnetting it. If you need understanding of subnetting, you can go through one of the courses. Apenic has a course around IPv6 deployment, and that comprehensively covers the subnetting. Here's the New Caledonia report coming for that. Since we are in New Caledonia, we have OPT on top, so we see 25 adjacencies here for IPv4, while we see only 8 in case of IPv6. If anyone is here from OPT, please do add more sessions in case of IPv6. Make sure it matches. For the others, we do not see really many of the adjacencies, but I do see relatively less adjacencies in IPv4 as well. Possibly single home networks. If you are operating AS136.417 or 131.248 here, please do dual stack and start deploying IPv6. And with that, I do not mean roll it out right away on the last mile, but you can always start originating and make sure that your core is ready with that. Report for Fiji, again taken from today's morning time, so it's not older than 24 hours. We see Telecom Fiji on the top here in terms of the routes. It's actually similar to the other ASN which they are using, AS4638. Here it shows you the number. The number with IPv6 is certainly not good in case of Fiji. As you can see, a lot of zeros around there. Another one for PNG, we see only at this point of time AS17828, which I believe it's called Telecom, doing IPv6, while rest there's zero support. And remember, when I say support here, I am referring only to the support on the core. Here I do not mean that IPv6 is there on the access for these network, but that is the first requirement, that your core should support it. You should start originating prefixes. You should make sure that your peerings are dual stacked, and then start focusing on taking it out on the access. Else, a half-baked core is just going to cause problems with poor routing and higher latency. So that was about the BGP world. You may see some operators doing it, some operators may not doing it. That may not reflect the end user. What is there can be deployed on the access side. What is not there is definitely not there, and there's nothing on the access. What about the access side? So I can show you some of the data from the Apenic IPv6 measurement stats. It's a great project where Apenic is measuring it based on a certain print of the code which they give for advertisement, and based on the loading of that code, Apenic is able to map the IPv6 deployment. The green you see is good, and the red you see is bad. Here you can see for US, it is getting greener, and the other green places I can see on the map, Belgium somewhere here, and India, which recently became very green with respect to IPv6 deployment. One of the key reasons for this kind of behavior is because large mobile operators in these companies have started using 464 XLAT, and they see a good reason to do IPv6 on the mobile network. On many other cases, on the fixed line, it's still missing because the challenge of support on CP is still on the higher side against a cell phone device which you keep on upgrading every 3 or 4 years. How many of you have a router at your home which you have not changed since last 6 years? 6 years or more. Can you raise hand? If your router is more than 6 years older, please raise your hand. 3 years or more? That's okay. That's interesting. That's interesting. You probably we have very techie audience who is constantly changing their home router. That may not reflect the real world use case where a large part of CPA devices are really very old, and changing them is a hard task. While for mobile operators, it's not with the mobile operators to get the cell phone changed, right? With a lot of unbundled plans, people keep on switching phones, and with the modern devices, it's much easier. So in case of US, T-Mobile was on forefront in deploying IPv6. We have, in case of India, it has recently gone up with the Reliance Jio picking it up and deploying more and more V6, which is good. Here's the statistics again, taken from the from the Epinic IPv6 measurement. In case of if we go by region-wise and we distribute and we break it down in terms of percentage, North America happens to be on top with 43%. South Asia going further at 36%, actually chasing closely. In case of South Asia, it's essentially mostly one country, which happens to be India. Again, it happens to be mostly one operator, which happens to be Jio at this point of time. Others are catching up, which is always a good thing. There are countries in Western Europe as well as Northern Europe, but the sample size is much lower in these cases, again proportional to the population size in these countries. References about the talk, our toolkit, which is at bgp.he.net. You may go to the toolkit, see around routes. On the left side, you will see various options, including world report, where we are classifying all the ASNs in the world based on the country, and also mentioning about the V6 about the V4 versus V6 routes. Excellent stats from Epinic, which is Epinic IPv4 measurement maps, available at this URL. Jeff Houston is around here. If you have any questions about the IPv6 measurement, you can take it up with them. That's about it. Any questions?
Okay, any question? No more questions? Thank you, and Enric.
Thank you.
And one gift. So we still have the last one from Gu Jingheng from TWNIC, going to introduce IPv6 measurement.
Good evening, everyone. I'm Jun Hen, from TWNIC. Currently, I have the presentation about the Asia Pacific IPv6 readiness measurement. And the outline is the status of the 3 common measurement criteria in Asia Pacific, including the IPv6 allocation and the BGP of the advertisement. The second one is the service ability. The third one is the usability. And let me see the IPv6, the allocation, and the BGP advertisement. The source is from the RAP NCC. The average of the IPv6 BGP advertisement is 26.9% in the end of 2017. And 28.7% in August this year. And the growth rate is about 6.5%. And the rank one of in this criteria is Japan is 40. Just here. It's 46.6%. The second one is the Taiwan, the 44.29%. The third one is the Malaysia, it's 40%. in this year, China and Hong Kong have larger growth rates. There are 37.5% and 10.3% respectively. So this is the first common criterion. The second one is the IPv6 serviceability. The average of the IPv6 serviceability is the 13.89% in the end of the last year, and 10.88% in August this year. The growth rate is minus 21.7%. The data is from the ELISA, the top 1 million website for each CCTLD. And in this that one we can see the Indonesia is the rank 1 is the 20.88%. The second one is Thailand is the 17.14%. The Singapore is the third one, the 15.59%. In this year, also China and Thailand have larger growth rate. It's 155% and 12.2% respectively. So it's the second common criterion. The third common criterion is IPv6 usability. This data is also from the Epinic. The average of the IPv6 usability is 12.92% in the end of the last year, and the 17.39% in September of this year. The growth rate is the 34.6%, and the rank 1 is in India is the 50.42%. The second one is Malaysia is 37.49%. The third one is Japan, the 20.65%, and the fourth one is New Zealand, the 20.87%. And in this year, Taiwan, Vietnam, and Taiwan, Vietnam, Thailand, and Malaysia has the growth rates, and Taiwan is 3,673%, and Vietnam is 90.7%, and Thailand is 90.2%, and Malaysia is 80.2% respectively. So in these three common criteria, the conclusion, the ratio of the two common measurement criteria, the first IPv6 allocation and BDP advertisement, and the IPv6 usability are growth. Those are 6.5% and 34.6% in this year. And the growth rate in IPv6 usability shows that most Asia Pacific countries make big progress in the IPv6 deployment. And the growth rate of the IPv6 serviceability is negative for many countries. So we observe the many content providers needs to be encouraged to apply IPv6 services. So in the future. So it's on my presentation. Thank you very much.
Any question? No question.
Okay.
One
Okay,
tip still
thank
for you.
Yeah.
Thank you all the speakers this section and all the participants, and I conclude our section adjourned here. Thank you.